Welcome to the fastest way to learn data structures and algorithms with premium revision material. Today we master LeetCode 63, Unique Paths 2. This is a classic grid dynamic programming interview staple where you count every valid route from the top left corner to the bottom right corner while dodging obstacles. Look at the problem statement. You receive an M by N grid. Each cell is 0 for open space or 1 for an obstacle. A robot starts at the top left cell and wants the bottom right cell. It may only move right or down. Return the number of unique paths that never step on an obstacle. If the start or finish is blocked, return 0. Imagine a delivery robot on a downtown street grid. Open blocks are clear intersections. Obstacles are construction zones painted red. The robot can only drive east or south, never northwest shortcuts. At every intersection it asks, how many distinct routes from the warehouse could have brought me here? That running route tally is exactly our DP table. Strategy time. Trick name grid DP path counting with obstacle guards. Build a DP grid matching the input size. Each DP cell stores how many unique paths reach that coordinate. If the input cell is an obstacle, force DP to 0 because no route may enter. Otherwise DP at row I column J equals paths from above plus paths from the left, treating missing neighbors as 0. The answer lives at the bottom right DP cell. Enter the spoon-fed detailed dry run. Example grid is 3 rows by 3 columns. Row 0 is 0, 0, 0. Row 1 is 0, 1, 0. Row 2 is 0, 0, 0. The obstacle sits at row 1 column 1. Display the obstacle grid on the left and a live DP scratchpad on the right. Initialization. Allocate DP table all zeros. Seed the start cell at row 0 column 0 with 1 path because the robot begins there. Cell row 0 column 0. Grid value is 0, open space. DP is already 1 from initialization. Cell row 0 column 1. Grid is open. Only the left neighbor contributes, DP becomes 1. Cell row 0 column 2. Grid is open. Left neighbor contributes 1, DP becomes 1. Cell row 1 column 0. Grid is open. Only the top neighbor contributes, DP becomes 1. Cell row 1 column 1. Grid value is 1, obstacle. DP is forced to 0. No routes may pass through construction. Cell row 1 column 2. Grid is open. Top neighbor contributes 1, left neighbor contributes 0, DP becomes 1. Cell row 2 column 0. Grid is open. Top neighbor contributes 1, DP becomes 1. Cell row 2 column 1. Grid is open. Top neighbor contributes 0, left neighbor contributes 1, DP becomes 1. Cell row 2 column 2. Grid is open. Top neighbor contributes 1, left neighbor contributes 1, DP becomes 2. This is our final answer. Scan completes. 2 unique paths survive every obstacle. Highlight both valid routes on the obstacle grid. Pivot to Python implementation. Define unique paths with obstacles on obstacle grid. Guard blocked start. Read row and column counts. Build DP table of zeros and seed the origin. Nested loops walk every cell. On obstacle, set 0 and continue. Otherwise add contributions from above and left. Return the bottom right DP value. Complexity audit restated crisply. Each cell is visited once, giving time O of m times n. The DP table stores m times n integers, giving space O of m times n. The add above plus left recurrence is the interview pattern for counting paths on grids. And that is Unique Paths 2, mastered for your next on-site. If this helped you today, like the video, subscribe to Leo Academy, and share it with friends who are preparing for coding interviews.